Welcome back to another video, guys. And in the previous video, we are discussed about what are operators and operands, and types of operators like arithmetic operators and relational and logical operators. We have already discussed, and the two types of operators we have remained, which is bitwise and assignment operators, which we are discussing in this video. So let's start this video. So first, before discussing bitwise and assignment operators, we have to discuss about the basic concept, which is precedence and associativity of operators. So it is the topic which we have read in our mathematics about board mass. We have known it as a board mass rule, in which we have defined the priority of operators. Like in an equation, we have many types of operators, so we decided the priority of operators, which operators has the highest priority. We solve that that operation first, and after that we solve the another operator. So it is same like that. In operators, we have the precedency and the postfix, which are the brackets, which is small curly and big brackets, have the highest precedency if they are in the equation. So compiler first solve them and then after switch to another operators. And after postfix, we have unary operators, which are increment and decrement. Okay, then after we have multiplicative, divide and modulus operators, which has the lower priority than unary operators. And after that we have additive operators, which are addition, subtraction, so they have the lower priority than the multiplicative operators. So associativity of operators is when an expression contains two operators with equal priorities, the tie between them is settled using associativity. Like we have two operators, we have multiplication and division. So in that case, they both have the same precedency. So we use associativity, and associativity defines the flow of solving an equation. Like if we have the same precedence of brackets, like we have two small brackets, then it will solve by left to right. So the postfix has the precedency of left to right, but unary has the precedency of right to left. If the two unary operators have the uh, are in the equation, so it has to be solved from right to left, and then multiplicative have left to right and additive have left to right. So most operators having the associativity from left to right. Okay, so these are the two basic concepts which we have to remember. And after that we have to discuss about the bitwise and assignment operator. So let's go to our program file and discuss there. Okay, so first we discuss about bitwise operators. It is a bitwise and, it is a bitwise or, it is a bitwise XOR, and it is a left shift, right shift, and a complement operator. All right, so we are discussing all that with an example. So go to our coding page, coding file page. All right, so it is our operator file. So we are opening our operator file in Notepad word editor. Okay, all right. So I have already these are the logical operators which we have studied earlier. So I have clear all the code. All right, so we have the class operator, and operators.java is the file name. Yeah, so this is our file, and first we discuss about the and operators and or operators. First I will write what are the different bitwise operators. This is known as bitwise and and it is bitwise or I have to zoom this. Okay, and okay, bitwise XOR, it is left shift and is right shift. All right, so we have all this type of bitwise operators we have. All right, so first we discuss about what is the operation which is performed with the help of bitwise AND. So first I will take a integer value like I is equals to मैं ले लेता हूँ 6 and all right, int I j is equals to मैं ले लेता हूँ 4 and there we perform the bitwise operator between them and let's find what is the value it is written by the bitwise AND. Then after we will discuss about it. Okay. I have to perform the bitwise and operation between I and j. Let's see what is the result. First save this file. Now opening command prompt in our main file, java c operators operator.java. Now compiling our code, java file name, I have to the file name operator. All right, so it is given as the 4. Now try to understand what is the logic and how the AND operator works, bitwise AND works. So we know the bitwise byte value of 6 is 110 and we put 0 for convenience. Okay, so it is the value of 6. All right, so we have the value of 6 and now we check what is the value of 4. So value of 4 is 0 0 and then sorry 0 1 and then 0 0. So it is the bit value of 4 and it is the bit value of 6. It is the 2 to the power 1 and 2 to the power 2, which is 4 plus 2 is equals to 6 and it is the 2 to the power 2 which is 4. So we have this type of values and operation performs like when it has the both the value of 1, then it will take a 1 as a result. Like there are two zeros in the first, so it takes a 0 and then after 1 0 pair, so it takes a 0 for them also. And if it get 1 and 1, so if it get both the true values, 1 is treated as the true value for it. So if it gets 1 1 on both hands, so it will take 1 as an result. So we get the result is result okay, r for the result. So there we get the 0 for 0 and there we get both the true values, then we take 1 and there is one value is true which is which is in the sixth, so we ignore it and take a 0 and then after we again get both zeros, so we take 0, so it is equals to 4. And that's how the AND operator works. If it gets both the true bit values, then it returns as the then it will take 1 as a bit value in its output. All right, okay, so it is the AND operators working and now it is about OR operators. So we change the sign All right, I change the sign and save this file, and again our command prompt compiling our file. So it give us 6 right now. Okay, so let's again try to understand why it is giving us a 6. So 6 has the value, we know that 0110, and 4 has the value which is 0100, and then our result has the value is, so okay, so in our operators, any of the condition is becoming true, so it will return as the true, we know that. So it is similar in the bitwise, or if it gets any pair, any value is 1, then it will take bit as a 1. All right, so here in the first comparison we get all the both the values is 0, so it takes a 0, and then we get both the values 1, so it takes 1, and then in another comparison we get one value is 1, so we get take 1, and another both values are 0, so 0, and this is equals to 6, we know that, so that's why it returns 6. So the basic concept of and or follows in the bit, so they known as the bitwise and bitwise or. All right, now performing XOR operation. All right, so I have changed the sign to XOR and compiling my file. All right, so here we get the 2 as a output. Let's again try to understand. Okay, so we have the value of 6 is 0 1 1 0, and we have the 4 which is equals to 0100. All right, and our result which is equals to 2, and here is the XOR concept applied in that. So we know that in XOR, if we get both the values are same, then it takes a 0 as the output in that, and if it gets a different pair of values, then it takes 1. All right, so the concept is same applied here. So first we get the both the zeros, then it takes zeros, then we get both ones, and we know that if we get both same values, then we take 0 as an output, and here we get both are different values. For different values we have to take 1 in that, and for same values we have to take 0, and which is equals to 2, we know that, so that's why the output is 2, and that's how the XOR, similar concept of XOR we have studied in the operating systems and also in the physics, that if we get both the same values, then we take 0, and if we get different values in XOR, so we take 1. Okay, so that's how the XOR works in the bitwise. Okay, so left shift and right shift we have remained, and for left shift I have to given a number like how many times, how many number I have to left shift. So like I have to left shift I by 2 numbers. Okay, so first let's check the output, and then after we will discuss with the bitwise values. All right, I somehow closed now compiling our file operators.java, and now run our file. All right, so we get 24 as an output. So let's try to understand what will happen there. Okay, so we know the bit value of 6 is equals to 0 1 1 0, and we left shifted two values, like we have added left shifted, like here is the value and we shifted this value by two numbers, so we have to add two zeros at the last of them. Okay, so the values become like here okay, so it is the value of, it is our value, and we left shifted it, so the two new values are added, and which and those values are 0, so two zeros are added. Now we have to check this value, what the value is become. It is the 2 to the power 1, 2 to the power 2, and it is the 2 to the power 3, which is equals to 8, and it is the 2 to the power 4, which is a 16. So 16 plus 8, which is equals to 24. So that's how the left shift works. We shifted our whole values to the left, and the remaining space is filled by the zeros. Okay, so this space is filled by the zeros, and if we try to left shift our 6 with 3, so the so we try to expect that the another 0 will be added, and the value is become, now it is the 2 to the power 4, so it is a 16, and it is the 2 to the power 5, which is 32, so the value become 32 plus 16, which is 48. So we are expecting 48 will be the answer. Let's check it. Okay, I have to save it, then compiling our file, run our code. So we get the output is 48 if it is not visible. All right, so 48 is our output, and we understand how the left shift works, and left shift is similar to right shift. Okay, I will here show you. It is the symbol of right shift. Okay, it is, we are shifting three values to the right. Okay, so we are shifting I, and what is the value of I is 0 1 1 0, and we shifted three values, so we get three zeros in the starting, then after we started our value, so we get the 0 as an output, and let's check it that we get 0 as an output or not. We get the 0 as an output, like here I will show you. It is our value. Let me remove this 0, extra 0. It is our value, and we right shifted our three values, so we right shifted, so we delete these three values, and on the place of these three values zeros are added, like this value become like a 0. Okay, and if we try to left shift for, let's try it. Okay, right shift, sorry, we right shifted, so we get another 0 also. Okay, if we right shift only two values of I. Okay, so here is our value of I is 110, and we shifted only two values, so we have to delete only two values, and for that two values we are adding two zeros in the front of that value, so our value, so our answer would be 1, and we are expecting 1 as an output. Let's see if we get 1 as an output or not. Here we get the 1 as an output. Let me zoom it. It is clearly visible right now. Okay, so that's how the right shift and left shift works. Okay, we have remain only one another bitwise operator, which is the complement which bitwise operator. Okay, Okay, so let's check it. If we have the value of I, and I have to know the complement of I. What is the complement of I? So I have to add this sign in front of I. Okay, uh, it gives us the complement of I. So I will save this file and compile it. It gives us the -7. Okay, so let's check why it is give us the -7 value. And basically it give us the complement of that number, which is equals to minus of n, and which is equals to minus of n plus 1. So it is the formula of complement. Like if we give a 4, then the answer of that complement is 4 plus 1 5, and it is the minus. Let me show you complement of I, complement of j, which is equals to -5. So yeah, that's how the complements works. And it basically changes the zeros into ones and ones into zeros. So that's how complement works, and it gives us the -5. So we have completed our all the bitwise operators, and also with an examples. So if you like this video, so don't forget to like, and any suggestions, so please uh, write your suggestions in the comment box. Thank you. And now we have remained the assignment operators. So assignment operators are very easy. They are just assignment of assigning of values. Here I will show you there are two types of assignment operators. First is simple assignment operator, which is equals to, it is the simple assignment, and it is a compound assignment operator. So these are the compound assignment operators, which are the plus equals to, um, minus equals to, and divide equals to, and multiply equals to. Okay, so these are the compound assignment operators. We all know that int I is equals to 6. So it is a simple assignment. We directly assign the value to a variable. Okay, so I do not need to show you that how assignment operator works, but I will show you how compound assignment operator works. Okay, so I will take int I is equals to 10, and here I have to assign I with a plus is equals to 9. All right, so this plus means this equations basically is equals to I is equals to I plus 9. Okay, so it is the shortcut of writing this equation. Like I do not have to repeat this variable writing again and again. So I have write it simply by using compound assignment operators. Okay, so this is the basic structure of that equation, and it is the shortcut assignment of that structure. And here we will print out what is the output of that I. Wait. Okay, I have to compile this file. Here I will run, and here we get the 19. So it doesn't add a new thing. It basically provide us the shortcut of writing an equation. So we write that, and simply we can perform different operations. Like I have to subtract 9 from I, so I have used minus in place of I. Let's check. We have to get the 1 as an output. Here we get the 1 as an output. Okay, So it is basically assigning and performing operations with the same variable in which we are assigning. Okay, so these are the operators. I have completed all the operators arithmetical. If you do not see this video, so watch the previous video. I have discussed all upper three operators in that video, and the two types of operators we are discussed in this video, and also the what is precedency and what is the associativity of operators in this video. If you like this video, so don't forget to like, share and subscribe. Thank you.